Today is the Kubernetes first class. So as you know, before discussing whatever I learn, I compare with real life example. So I will show you the real life container shipment. Right. I hope you have booked some products from Amazon, right? Whenever you book a product from Amazon, how the product shipment will happen that is within country, right? Right now I'm in Andhra Pradesh. So whenever I book anything within India, so what they will do? First they will check the address, right? They will verify the address. Then after they will pack my product and they will ship to my home, right? This is the normal process which happens whenever you purchase anything from Amazon within India. So for suppose if I want to ship this product, okay, to other countries, what is the process will happen in real life? So outside country, so what they will do, they will ship your product inside a container, nothing but, if you see, this is the container, this is called as containers. What they will do, they will pack your product safely within the container so that your product will not damage. It might be product, it might be a vehicle, whatever it may be, just they want to ship the product safely to the other country. In order to do that, they will safely pack your container inside the container, and after packing they will keep. So there are so many containers which needs to ship to the outside country, okay, like this. Okay, you can ask me why only we are using ships to transport the products. There will be like other options as well, right? We can use bus, we can use train, and we can use flight. So if you use bus, there will be a huge traffic, your product may not deliver within the time, right? There is one advantage of bus transport. Like train, if you want to, train also slow compared to bus, train is very slow, right? And at the end, what we need to save the time, we need to ship the product. But if you see, if you use ships, we can send hell lot of products at a time using ship. You can ship the product and your product is out, like it was inside the container. Even if the container falls down, you can again take that container because your product is not damaged. Only the container, it is already protected inside the container. Anyway, it will not fall down. I'm just telling. So like this, if you see, like this, they will kept many products inside the container and they will ship. It might be bike, it might be car transportation, it might be like, it might, whatever it may be. Just imagine this is a product. Like this, the product shipment will happen, right? Like this, they will send your product to the other countries. So if you see, this is huge ship with a lot of containers, so that you can ship your product fastly to other countries. And if you use the sea, if you use the ship, there will be no traffic and you can transport your product as fast as you can. So whatever you are giving, like you are transporting the product, it is called as container ships, right? Container ships. Container is nothing but you just treat it as a box which is protecting your product. So this is what happened in real life. Now let's come back. In the same way, how we are protecting our product, just in the same way we are going to protect our application inside a container. Whatever developer written the application, that's part, the technical part will be discussed. Right now only the major focus was just real life example, and you got some clarity how the products will ship to the outside countries, how how our application will work inside the container. We are going to discuss in upcoming sessions. But just imagine, container is nothing but one type of box which protect your application, that's it. Now I will show you what is this Kubernetes. So let's say you have created an application, right? You have created an application, you want to share that application to the world, right? Okay, I have created a application which type of, which call it as Zomato say booking application, and I want to share with the world. What I will do? So I use Docker container to package the application. So as I said, right, if you don't know container, I already shown you container nothing but it's type of box. In that box your application will be safely kept. So Docker should make my application work the same regardless of the environment. So it doesn't matter where, whatever environment it may be, your product will be safe inside the container. So, and for that I've used Docker container to package the application. So I packed my total application inside a container. Okay. So say you have deployed on 3 different servers using Docker. Your application starts getting massive traffic. So your application is doing better. So you have deployed your application inside the 3 containers, and it is running on 3 servers, and your application got huge success. People are using your application and you are getting huge traffic. So if you see, he is happy because he is getting visitors and he is happy with the website. So now you need to scale up fast, because once you get scaling, once you get a huge traffic, what you need to do? Just a moment. Yeah, Nasrin, please try to join before itself. So what now I want to scale. So you need to scale up fast. How you will go from 3 servers to 40 servers? That you may require, because I am getting huge traffic. Right now I am running 3 servers, but I want to scale it automatically to 40 servers. Like how to decide which container should go where? Right, there is only 3 containers and your application was running. Which container you need to scale? You don't know how to scale that. You need to monitor all the containers, right? Inside the container your application is safe or not, you need to monitor that, right? There are so many things you need to do. How you will do it? So how I am going to manage all this? So I need to restart, right? And would it be easy if there is any it will be handled automatically by a system? So this is where Kubernetes comes into play, right? Kubernetes akka k8s. In the short form, Kubernetes will call it as k8s. So if you see K, yes, in between there is a 8 letters. That's the reason it is called as k8s. And it is an open source container orchestration platform that automates deploying, managing, and scaling containerized application. So I said, right, what is this container? Container nothing but it's protect your application, that's it. Okay, I want to, whenever I get a huge traffic, I want to scale this container automatically. So Kubernetes will help us to scale your containers automatically depending upon the traffic. That is the major use of Kubernetes, right? So how it works, how Kubernetes will work? You are telling you Kubernetes will scale, but actually in the background how Kubernetes will work, that's what we are going to discuss. So Kubernetes cluster consists of set of working machines called as nodes. So Kubernetes will be having a master and nodes. Okay, master and node concept, and it will run the containerized applications. So every cluster has at least one worker node. Hence, if the node fails, your application will still be accessible from other nodes, as in a cluster multiple nodes are grouped. So if you see, this is the master, this is the nodes. Your application will run inside the nodes. For suppose due to some reasons, if this node got failed, you no need to worry. Your application will be working on another node, so that your application will not get downtime. So that is the advantages of Kubernetes. That's what they have written here. And now we need to discuss about the Kubernetes architecture. So in every interview they are going to ask you what is the Kubernetes architecture. Can you able to tell what are the master and node components, they might ask. Okay, every node contains a container runtime. So inside this container runtime your application will be going to run. So what is this container runtime? Just ignore, this is the first class, you will not understand. In upcoming sessions you will slowly understand. And there is also a kubelet. It will help us to start and stop and manage containers by requesting to Kubernetes control plane. And what is this kube proxy? And it will manage the networking and load balancing. So if you see, this is the master node components. I said right, Kubernetes architecture nothing but master and node. So this is the master and node components. If you see, in the master you will be having API server, scheduler, controller manager, etcd. And master supports only Linux operating system. Master only supports Linux operating system, it will not support Windows. So what are the Kubernetes master components? API server, scheduler, etcd, controller manager. So what is this API server, what is this scheduler, what is control manager, we are going to discuss. But right now just remember this, we will be having inside the master there is a kube API server, scheduler, etcd and controller manager, and it supports only Linux operating system. And node, master and node component will support Linux and Windows both. Inside the node you will be having kubelet, container runtime. I said right, inside this your container will be running. Kube proxy, load balancing and networking will be provided to the node using this kube proxy. And kubelet, this is using this kubelet, what I said, we are going to start and stop the containers and manage the containers. So if you see, whenever you work on Kubernetes, you need to install Docker compulsorily, because at the inside the Kubernetes what we are using containers. Container nothing but a technology. What is a technology? Which is nothing but Docker. So if you are using Kubernetes less than 1.23 version, you need to install Docker, your Kubernetes cluster will work. If you are using greater than 1.23 version, you need to install Docker as well as containerd, which is cryodockerd. So what is this? Just don't worry, we will discuss. So now let's come back to our session. So why Kubernetes? Why only Kubernetes we need to choose? What are the advantages of Kubernetes? We are going to discuss. So when we run our application in Docker container, right? For suppose if you use Docker to run the application inside the container, so whenever you run an application inside Docker container, if the container fails, you need to manually start the container. Right? If you are using Docker, you need to manually do everything. Like if the node, that is the machine fails, all the containers running on the machine should be recreated on other machine. Right? If like for suppose if you are running in Docker, like if server is fail, then what you need to do? You need to create one more server. You need to create all the containers again. But what is the advantage of Kubernetes? Kubernetes can do both of the above. Nothing but Kubernetes can able to, if the machine fail, what Kubernetes will do? Already there is another node will be there. What he will do? He will shift all the containers to another node. So what auto scaling. So containers doesn't scale on its own, on their own, right? Scaling will be of two types. One is vertical scaling, another one was horizontal scaling. Vertical scaling nothing but you will increase the CPU and RAM of your server. Horizontal scaling nothing but you will create one more server. That's it. So Kubernetes support both horizontal and vertical scaling. So zero downtime deployment. So Kubernetes can able to handle deployment with zero downtime. Nothing but there will be no downtime. And Kubernetes had a rollout feature as well. Rollout and rollback. Nothing but if one version is not working, you can go to previous version. That will also supports Kubernetes. So Kubernetes was described as production grade container management. Nothing but you can run your application in production environment. That is the description of this. So what is the history of Kubernetes? We need to know, right, how this Kubernetes was born. So Google had a history of running everything on containers. So Google is the founder of this Kubernetes. To manage these containers, Google has developed a container management tool. Okay, what this container management tool Google has created, which is Bog and Omega. It's a own product of Google. So whatever Google search engine you are using, where it is running inside a containers. Whenever Google get a huge traffic, what it will do, it will automatically scale the containers. Because why you are scaling the containers? So to manage the application, if you scale the containers, it's nothing but horizontal scaling. Container nothing but one type of server. Okay, treat this container as one server. If I getting huge traffic to one server, my server will crash. What I need to do, I need to create one more server. Then using load balancing, I can send the traffic to one server to another server. In the same way, container nothing but one type of server. So with Docker publishing container, with the experience in running and managing containers, Google has started a project Kubernetes, which is developed in Go language and then handed it over to Cloud Native Container Foundation. So CNCF, nothing but Cloud Native Container Foundation, is a open source organization, nothing but open source community, which manages this now Kubernetes, because Google has started a project Kubernetes and he has donated this Kubernetes to this company. Now this company is managing the Kubernetes. Google has just handled over it. Nothing but he has donated. Google has donated this Kubernetes project to the CNCF. This is the history about. Okay, what is the competitors for Kubernetes? You need to know, right? One is Apache Mesos, another one was Archicop Nomad, and one more thing was Docker Swarm. You know about it. But here Kubernetes is the clear winner. If you see everywhere, Kubernetes, Kubernetes, Kubernetes. Even though if there is a competitors, still Kubernetes is a clear winner. Now we are going to discuss about, like, initially, like, Kubernetes is not designed only for Docker. Okay, initially Kubernetes was used Docker as a container platform. Kubernetes only supports Docker as a container platform, where initially in the beginning, after Kubernetes 1.24 version, they have supporting every container technology. There is a Docker called as, which is famous container technology. There is also a Rocket, which is one type of container technology. So there will be many companies which is providing a container to run your application. So Kubernetes is designed to run any container technology, right? For this, Kubernetes experts container technology to follow Kubernetes interfaces. So they need to follow the Kubernetes rules, just like that. Now we are going to discuss about official architecture. Right, using kubectl, nothing but it's a CLI. We are going to communicate with this is the master, this is the node. I said, right, what is the master components? API server, controller manager, etcd, scheduler. What is the node component? Kubelet, kubeproxy, container runtime. What is this? We are going to discuss briefly. So you need to remember this. In the interview, they ask what is the master component. You need to tell API server, scheduler, control manager, etc. What is the node components? You need to tell kubelet, kubeproxy, and container runtime. How you are going to remember this? You need to practice. Then only will remember. So what is the master components? API server, scheduler, controller manager, etc. And master will support only Linux operating system. What is the node components? Kubelet, container runtime, kubeproxy. It will support Linux and Windows operating system. So what is the logical view? Whenever you want to run any Kubernetes command, you are going to use a kubectl, and it will be shown as directly to Kubernetes. But in the background, it was work like this. So whenever you execute kubectl, first the request will go to API server. From API server, it will go to scheduler, container runtime. Like this, they will manage. How it will manage, I will explain. Don't worry about it. Right? If you see, whenever you hit anything, first it will go to API server. Whenever you request anything using kubectl nothing but a command to communicate with this cluster. So there is a master components and node components. Whenever you execute any command, the request will go to API server. What API server will do? API server will store the information in etcd. Etcd is nothing but a database. Like for suppose whatever you have created, that information will be stored in etcd. And there is a control manager and scheduler. It will schedule the pods, and kubelet is a worker agent. It will run the containers, and kubeproxy networking component. Everything I will discuss briefly. Now let's come back to the kube API server, etcd, kube scheduler, control manager. And cloud control manager will be comes into the picture when you are running on Kubernetes cluster on cloud, nothing but AWS or Azure cloud. Node components will be kubelet, kubeproxy, container runtime. So what is this kube API server? Now we are going to discuss one by one. So handles all communication of Kubernetes cluster. Okay, what is the job of API server? It will handle all the communication of Kubernetes cluster. Let it be internal to the cluster or external to the cluster. So kube API server exposes functionality over HTTPS protocol and provides REST API. So how it will expose? Using HTTP protocol. And what is this etcd? I said right, it's a nothing but database. So this is the memory of Kubernetes cluster. What is the scheduler? It will schedule. Scheduler is responsible for creating Kubernetes object and scheduling them on right server. So scheduler will know what is a healthy node. It will just schedule the container on the healthy server. What is the job of scheduler? It will schedule the Kubernetes object, nothing but it will create a container. Where it will create a container? On the right node, nothing but on the healthy node. What is kube API server? Whatever you execute any command, first request will go to kube API server. From kube API server, it will go to scheduler. Scheduler will tell and check this is the request we got, and again the request will go to kube API server. Like this, everything will comes to kube API server. All communication of Kubernetes cluster. So what is this controller manager? So controller manager is responsible for maintaining desired state. So what is this desired state? We are going to discuss. For now, just imagine, like for suppose if I tell Kubernetes cluster I want to run 5 containers, controller manager will check whether the 5 container is running or not. For suppose if one container was failed, controller manager will automatically create one more container. So it will manage this state. So what is a kubelet? So this is an agent of control plane. And what is a container runtime? Inside this container runtime, your container technology will be used. So it might be Docker, it might be Rocket, but in our case it's Docker. What is a kube proxy? I said that inside the container, how the network will get. So this component is responsible for networking for containers. So right now we are discussing kubectl, right? This is the command line that can installed on the machine from which you communicate to Kubernetes cluster. How you can able to create the communicate with Kubernetes cluster? Using kubectl, you are going to communicate with the Kubernetes cluster. Inside the Kubernetes cluster, the request where it will go? It will go to API server. So you will understand. It is the first session, right? It will be a little bit confusing. You need to watch the recording once more again. Then slowly you will understand the concepts. So DevOps is very tough. In the beginning, you will not understand anything. You will just get only 10%. Once you watch recording again and again, you will get some clarity. Then after you can practice. So this tool is created to make communication with API server simplified. So you can easily communicate using kubectl. So kubectl also has a configuration file, which is kubeconfig file. I will show this kubeconfig file whenever we created a Kubernetes cluster, right? In tomorrow's session, we are going to create a Kubernetes cluster, right? Then I will show you what is this kubeconfig file. So inside the kubeconfig file, what will be having? You will be having the information of your cluster and how to communicate with API server. That information will be present. So you can communicate with the cluster using two. One is imperative, one is declarative. Declarative nothing but you can write a script. Using this script you can communicate with the Kubernetes cluster, or you can directly by commands you can communicate. There is a two. One is imperative nothing but directly you execute some commands. Declarative nothing but you will write some YAML files. So what Kubernetes kubectl will do? It will read the manifest and connect to API server. So it will convert the manifest into REST API, right? Kubernetes doesn't understand this YAML, so it will convert the as per the request. It will convert the REST API and calls over JSON. Like whenever you get any output, it will get as a JSON output. What is this? We will discuss. If you see practically, then only you will understand. So what is the Kubernetes manifest? I said that this is a YAML file, which you like whatever container information will be present inside this YAML file. So what is the CI/CD workflow? As a DevOps engineer, what is the workflow? So whenever you get during Docker sessions, I said right, whenever we get a new code, what we will do? We will create a Docker image with new version, and we will push the image to registry. So using that image, what we will do? We will deploy this into the Kubernetes cluster. So this CI/CD workflow, if you want to create, we are going to use a tool called as Jenkins, right? Using Jenkins, what we will do? We will create a image with new version and we will push the image to registry. Then after we will this deploy into the Kubernetes cluster. So if you are using Azure DevOps, same thing. In the Azure DevOps also, you will, if you use pipeline as Azure DevOps, you will create a Docker image, you will push the image to Docker Hub, then you will deploy it to the Kubernetes cluster. So if you are using Kubernetes as a service in the clouds, so all popular clouds are offering Kubernetes as a service. Azure was provided as a AKS, Azure Kubernetes service. AWS provided as a EKS, Elastic Kubernetes service. Google was provided as a GKE, Google Kubernetes Engine. So Google is the main founder of this Kubernetes, you know about it. So all cloud providers manages control plane for you and they charge hourly. So the cost of the Kubernetes cluster will be hourly charges. For nodes, we pay the similar cost of virtual machines. So I said right, inside the Kubernetes cluster, you will be having master and node components. Master will be managed. If you are running your Kubernetes, master will be managed by cloud provider. Node will be managed by us. So the master will not be visible to you. Only nodes will be visible. So you will get understanding about this in upcoming sessions when once I created a cluster. So how you will package the application? I shown you the real life example. Your product will be packaged inside the container. But how the application will be packaged, you need to know, right? How your application will be packaged inside the container. So if you see, in Kubernetes there is a deployment. Inside the deployment you will be having pod. Inside the pod you will be having container. Inside the container your application will be runs. So like if you see, this much of protection was providing to your application. Obviously every company will use, right? Just give me a moment. So what is this deployment? What is this pod? Right? We are going to discuss. Just don't worry. Our major focus was to how you package the application. That's it. How the Kubernetes work. So these things we are going to discuss. So first what we will do as a DevOps engineer, we will create an image for your application. How we are going to create application, and we will push the image to Docker registry. So using that image, we will wrap our container inside a pod. So pod is deployed into Kubernetes cluster via declarative manifest file. So we will write a manifest file. Using that manifest file, we will deploy the application inside a pod. So what will be the next? So in the next session, we are going to install Kubernetes. Nothing but from tomorrow onwards, the practical part will be started. So tomorrow I will create this Kubernetes cluster. Now I will come back. If you see, this is the architecture. So master and node, I said, right? In the master, what are the components you will be having? API server, controller manager, etcd, scheduler. In the worker, you will be having kubelet, kubeproxy, container runtime. Inside this container runtime, your container will be running. So just observe this arrow. I said that whatever the communication you will be having, it will communicate via API server. So what is etcd? Etcd is a memory for your Kubernetes cluster. It will show every information of your. How you will communicate? I forget it. Using kubectl, you will communicate with the Kubernetes cluster. Okay. Using kubectl, I am going to communicate with Kubernetes cluster. Whenever you communicate with Kubernetes cluster, request will go to API server. Right? Once scheduler will, what is the scheduler job? Scheduler will schedule the containers on the healthy server. But scheduler will not schedule it. Scheduler will go and tell to API server. Right? API server is a key component. Every request will come to API server. So kubeproxy networking. Networking within the cluster will be managed by kubeproxy. So kubelet will create a containers. Okay. Who will create the containers? Kubelet will create the containers. Once the container was created, kubelet will tell to the API server, hey API server, I have created the containers. So API server will have every information. What API server will do? Information will be stored in etcd. What is the control manager? It will maintain the desired state. I said, right, if I given 5 containers should be run. If one container will fail, automatically control manager will notify to the API server. Right? Then API server will go and ask to kubelet, hey kubelet, there is only 4 containers running. Try to create one more container. Then kubelet will create one more container and he will notify to the API server. So like this, every communication will comes to API server. So scheduler will schedule the container on the healthy node. etcd will store the information of your Kubernetes cluster. API server is the major component for the communication. Controller manager will maintain the desired state. kubectl will communicate to Kubernetes cluster. Kubeproxy will manage the networking part. Kubelet will create a Docker container. Right? If they ask in the interview, you need to explain what is the Kubernetes architecture. They will ask master and node components. You need to tell in the master you will be having API server, scheduler, controller manager, etc. And in the node we will be having kubelet, kubeproxy and container runtime. What is the job of scheduler? They might ask you. Scheduler will schedule the pod, right, or container on the healthy server. etcd will store the information of your Kubernetes cluster. API server will a major component for the communication. Controller manager maintain the desired state. Kubeproxy maintain the networking between the cluster. Kubelet creates the containers. kubectl will be used to communicate with the Kubernetes cluster. So today's session we doesn't discuss anything, just we have discussed only Kubernetes architecture. So this is very important. In every interview the first question will be what is the Kubernetes architecture, or what are the Kubernetes master and node components. Explain me briefly about each component. If you can able to explain this, then 50% of interview will be success. So that's what today's session is about. So tomorrow what I am going to do, so I am going to create a Kubernetes cluster. How to install this Kubernetes on AWS cloud. I will create some servers in AWS cloud. I will create a cluster out of it. How I will install Kubernetes, simple. Now if you have any doubts,